Hi, this is Chris with Sanderson Test Prep, and we are continuing in Section 4 of Practice Test 1, looking at questions 7 and 8. So let's get into question number 7. It says here that in the graph we're looking at rooftop solar panel installations in 5 cities A, B, C, D, and E. And the question reads, the number of rooftops with solar panel installations in 5 cities is shown in the graph above. If the total number of installations is 27,500, what is an appropriate label for the vertical axis of the graph? Okay, so let's test these out, because that's really hard to figure out just from the question itself. We have to look at our answer choices here, and we have to get a look at the kind of units that they're offering as options to see what might make sense for this. So first, let's look at the number as our total, 27,500. So if we think of units tens, hundreds, thousands, tens of thousands, and we look at 27,500, we might instinctively say, okay, well, tens, that seems kind of small, right? If you're working in tens, if you had, 8 tens, that would be 80. And that's very small, for example, compared to 27,500. And even hundreds, even if you had 1,200, that would be 1,200. That's still very small compared to 27,500. So we might start, if we're going to test these out, maybe let's start down here. Answer choices C and D seem a little closer to where we would like to be. And we can start with either one. But let's start with C since it's only thousands. It might make the math a little bit easier in case we have to do some math. But you do, whenever you have a question that you have to rely on answer choices to provide you with context as to how to start solving the question, you want to at least look at the answer choices and see if you can get a ballpark idea of what numbers are reasonable. So here, thousands or maybe even tens of thousands might be reasonable for a number like 27,500. Now let's go to the graph and test those out. So we'll start with C. Let's say each of these are in thousands. Let's see what that would actually look like. So if these are in thousands, meaning each of these numbers that you see here is times 1,000 on this vertical axis. So here, this place would represent 9,000. This would be 5,000. This would be 6,000. This would be 4,000. And then this here, it's in between 3 and 4. So it would be about in between 3,000 down here and 4,000 up here. So this one, it looks like it's right in the middle. It's hard to tell exactly, but let's ballpark that as 3,500. And let's see what our total would be if we added those values together. 9,000 plus 5,000 is 14,000, plus 6 would be 20,000, plus 4 would be 24,000, plus 3,500 would be 27,500 if we added those together. And that checks out. That is, in fact, what it's supposed to be. So C is our correct answer choice. And just to show you what would happen if we tested out answer choice D, let's say we said tens of thousands, because 27,000 does have tens of thousands, right? So in its total amount, you would say, oh, well, 20, that's 2 tens of thousands. So let's see why it doesn't work for that. If each of these represented 10,000 on that vertical axis, then this first point here, if we were looking at this first column for city A, it would go all the way up to 9 10,000s, which would be 9 times 10,000 or 90,000. So already we're a little bit over. And when we see that, we would be able to say no thank you to answer choice D. So even if D seemed right when you first looked at it, which is totally fine on this question, you want to just make sure that you're actually checking it against the graph and confirming, because I think if we did that, even if we were leaning towards D, we might quickly lean away from it and take a second look and then start with answer choice C, plug that in, and then add it up and confirm that that does in fact match our 27,500. Now let's take a look at question 8. And they say, for what value of n is the absolute value of n minus 1 plus 1 equal to 0? Okay, well, let's try to create our own equation here. Absolute value of n minus 1 plus 1 equals 0. So to solve for absolute value expressions, first you have to get the absolute value by itself. So here you would subtract a 1 from both sides and get the absolute value of n minus 1 equals negative 1. And this is something that I want us to recognize right away as soon as we see it. Can absolute value expressions be equal to negative numbers? And the correct answer to that question is no, absolutely not. Absolute value is measuring a distance away from 0. So you'll always get a non-negative result, because if you are at -4, for example, the distance is still 4. You are 4 units away from 0. And if you're at +4, you're still 4 units away from 0. So you'll never have a negative value as the result of an absolute value expression. And if you ever recognize that, you can stop right then and there. You don't have to do another thing. You don't have to do one more calculation on that question. You can go ahead and pick your answer, which we see here in answer choice D. There is no such value of n on a question like this. So that's a really important takeaway for absolute value expressions. Make sure that you don't just fall into trying to do numerical calculations without keeping in mind the context and the content required to answer an absolute value question like this. Up next, we'll continue with the multiple choice.